Okay, today's lesson also looks a little bit different than what you have in front of you, but again, just follow along and you should be okay. This first example is the same as your example on the front of your packet. Complete the table by writing the image of each point on the graph after a reflection across the line y equals x. My table is down here a little bit. Alright, the point on the graph of f of x, which I probably should have written f of x, you guys have it on your paper already, is 2 to the x power. When I find the inverse, what you do is you switch your x and your y values. So the point on the graph's image, instead of being -2 and 0.25, is 0.25 and -2. All I'm asking you to do is to switch the rest of the points. So the next one's going to be 0.5, -1. And then 1, 0. And 2, 1. And 4, 2. They already have the one plotted for you. And give me a sec and I'll try to graph it quickly here. We have our XY axes. Every other line is labeled, it looks like. So 1, 2, 3, 4, 5, 6, and -1, -2, and up to 6. 1, 2, 3, 4, 5, 6, and -1, -2. The points, they already plotted the first one, but again, I have to plot it, so just give me a sec. -1.5, 0, 1, 1, 2, and 2, 4. So that's what you have on your paper. They also show the line y equals x, which I'll do my best to draw here. Okay, and now we also want the image, which you guys can graph at this point as well. So 0.25, -2. And then 0.5, -1. And then 1, 0. And 2, 1. And 4, 2. So we found the points, we plotted and labeled the image of each point, and we used the images of the points to sketch the graph of the inverse, which is my blue. Now it says the domain of f -1 of x, meaning the inverse. So the domain of the inverse will be, if I look at my x values, if I look at my blue graph, it's going to go down forever, and then it's going to go over to the right. It is not going to go past the y-axis on the left-hand side. So none of these x values on the left are being used. So my domain has to be greater than 0. So my domain of the function is going to be x has to be greater than 0. The range, well, range is up and down. If I look at this graph, this thing is going down forever. It will also slowly go up forever. So my range is all real numbers for the inverse. Question 1b says, does the graph have any asymptotes? An asymptote is a line that it'll get closer and closer to but never actually hit. Well, this graph does have an asymptote. We can see here, this is getting closer and closer and closer to the y-axis but never actually hit it. So that's called an asymptote. So the graph has an asymptote at, now the equation of the y-axis is x equals 0. And the reason is because the graph will approach x equals 0, but never touch it. The value of the inverse of x, this is, does the graph, or 1c, how does the values change as x increases without bound? So as x is increasing, it is asking what is happening to the function. And we can see that it is also increasing. So the values of f of the inverse of x increases as x increases without bound. Okay, let's look at example 2. So flip your page over, and again, you're going to have a lot of wording up there. It says a logarithm is an exponent to which the base must be raised in order to obtain a given value. For example, 2 cubed equals 8, so the logarithm base 2 of 8 is 3. And we write it as log base 2, 8 equals 3. We've learned that before. And this next piece, and you've also learned this as well, you have a common log, the base is a 10. I'm looking at the table. And the natural logarithm, the base is an e, and you know how we write it as an ln x or a log x instead of a log base 10x and a log base ex. The reason that we're talking about this right now is because the inverse of the exponential, what we did yesterday, is a log function. Okay? So that's why we're going back to logarithms again today after skipping them yesterday, because they are inverses of each other. So 2a and 2b are kind of just review a little bit. 2a says explain in terms of a logarithm how to write 7 squared equals 49 is the equivalent statement using a logarithm. Well, we're not going to explain it, we're just going to do it. So it starts out as 7 squared equals 49. From a few days ago, if I want to rewrite this, the exponent goes by itself. The base remains the base, so log base 7 of 49. For 2b, it's asking us to go the other way. We have log 1000 equals 3. If I write it in exponential form, it becomes 10. Remember, use base. The base is a 10. The exponent is a 3. S means stay the same. A means keep an equal sign. So equals 1000. And that's all I want to do for example 2. Let's flip to example 3. I'm going to do 3 of the examples for example 3 and leave the other ones for you. It says find each value of f of x equals log base 2x. First one says find f of 16. Well, when I see f of 16, I know I have to plug a 16 in for x. So it's going to be log base 2, 16. Well, to solve that, I set it equal to a variable. I'm going to use z, something different than x. Now to solve it, you use base. So it's going to be rewriting it 2 to the z power equals 16. We know 16 is the same as 2 to the 4th. Since bases are the same, set your exponents equal. So f of 16 will equal 4. Now let's do letter C. Letter C, same idea. You're going to say that it's log base 2 of 1/32. You're going to set it equal to a variable. I'm going to do, let's say, p. And do base. So it's going to be 2 to the p power equals 1/32. When we have a fraction, we can flip it. So it's going to be 2 to the p equals 32 to the negative 1. 32 is the same as 2 to the 5th times the negative 1 up there already. Since the bases are the same, set your exponents equal. P equals negative 5. So that's your answer for letter C. And finally, let's skip to letter E. We have, it says 1 equals, well, we want to find f of 1. So it's going to be log base 2 x, oh, not x, 1, equals a variable. Let's use r. Do base. 2 to the r power has to equal 1. Well, anything to the 0 power equals 1. Therefore, r equals 0. At this point, I'd like you to try the 2 problems I skipped on example 3, as well as try your best on example 4, and we will do the rest tomorrow in class.